Good morning, grade 12 learners. Good morning, teachers. I hope you must be familiar with me by now. My name is Mohapi, Mathematics Subject Advisor from Motheo District. So today I'm going to take you through some few concepts in Euclidean geometry and try to prepare you for this coming test that will be written next week, Monday. Today is the 10th. We all know that on the 17th of March, grade 12 learners will be sitting for a common test in the province. So I'm just going to take you through the possible questions in that test and see how to approach those questions. Thank you. As I've already alluded, one of the possible questions in this coming test will then be the proof of the theorems. Sometimes we as learners, we tend to ignore the proof. Remember, whenever you sit for a test or for examination, there is this section that we call the bookwork. Bookwork basically is where you prove the theorems or the rules. So for paper 2, we know bookwork takes 12 marks. So possibilities are some marks for bookworks will go for the proof of geometric theorems, those theorems in Euclidean geometry. So it is important for you as a learner to know the proof of those theorems. I cannot take you through all the theorems. I'll only take you to one of the theorems and then see from there. I'll try and do some applications. Thank you. Check. Let's go through this given diagram. In the diagram below, ABC is a tangent. You can see ABC, that line. ABC is a tangent. ABC is a tangent to the circle with center O at B. Prove the theorem that states angle DBC. We've got to prove that this angle DBC, let me mark it. We must prove that that angle DBC is equal to angle DEB. The two angles that I've marked, they must be equal. So that is what we are required to prove. The theorem states prove that angle DBC is equal to angle DEB. Thank you. Before we can start with the proof, let's start with the construction. Let's start with the construction. And in our construction, we draw diameter BF. Let me draw diameter BF. Here it is. It passes through the center. A diameter, that point is F. We draw diameter BF. We know that the line that passes through the center of the circle from this part of the chord to circumference to that other part of the circumference, that line is called the diameter. So a diameter divides the circle into two halves. So we have drawn diameter BF, and then let's join FE. FE. Here we join FE or EF. Thank you. Can I, just to try and simplify our workout, let me name this angle B1. Then here we've got angle B2, angle B3, angle B4. And then here let's name this angle E1, and this one will then be angle E2. Basically, remember the required to prove part. The question states prove the theorem that states DBC. Check DBC. Basically, DBC is our B, angle B1. We've got to prove that angle B1 is equal to, check DBC. DEB. Basically, it's angle E2. If I try and simplify the work for us, that is what we are required to prove. We've got to prove that angle B1 is equal to angle E2. Thank you. Let's prove now. Now here is the proof. If we look at the diagram, in our construction, we have said we have drawn diameter BF. Check BF is a diameter. So we know the theorem that states an angle subtended by diameter is equal to 90 degrees. An angle subtended by diameter is equal to 90 degrees. So you look here, you'll see that angle E1 plus angle E2 gives us 90 degrees because it's an angle subtended by diameter. Angle E1 plus angle E2, they give us 90 degrees. The reason for that statement is that That is an angle subtended by diameter. It's an angle subtended by diameter because we have drawn BF as a diameter. So BF subtends angle E, which is E1 and E2. So check again, O is the center. So we move from O, ABC is a tangent to the circle at B. So we say angle B1 plus B2 is equal to 90 degrees. Angle B1 plus angle B2 is equals to 90 degrees. Let's check the reason for that statement. Why? Can you give me the reason? Check out the reason, learners. Why do I say angle B1 plus B2 is equals to 90? The reason is because tangent is always perpendicular to the radius. You know the theorem that states a tangent to the circle is perpendicular to the radius at the point of contact. So that's why we say angle B1 plus B2 is equal to 90 degrees. Therefore, allow me to make B1 the subject of the formula. From here, you can see that angle B1 will then be equals to 90 degrees minus B2. 90 degrees minus B2. From this statement, B1, angle B1 plus angle B2 is equal to 90. We make B1 the subject of the formula. Then B1, if we make B1 the subject of the formula, B1 will be equal to 90 degrees minus B2. From this very first statement, E1, angle E1 plus angle E2 is 90. Let's make E1 the subject of the formula. If we make E1 the subject of the formula from here, check. It therefore means angle E1 is equals to 90 degrees minus E2. Maybe I should clarify something first. E1 is equals to 90 degrees minus E2. But check B2 and E2. What relationship exists between the two angles? Check angle B2, it is subtended by arc FD. Check E2, it is also subtended by arc FD. What is the relationship between the two? Thank you. Some of you are getting it right. You can see it's angle B2 is equals to angle E2. Why? Those are the angles subtended by arc FD. Those are the angles subtended by arc FD. Check arc FD. FD subtends B2, FD subtends E2. Remember, what do you want to prove? You want to prove that angle B1 is equal to angle E1. Angle B1 is equal to angle E1. That is what you want to prove. You want to prove that angle B1 is equal to angle E1. Then, if B2 is equal to E2, I can substitute here. Instead of B1, I can say angle B1 is therefore equal to 90 degrees minus, I can substitute B2 by E2 because B2 is equal to E2. So B1 is equal to 90 degrees minus B2. Now I substitute B2 by E2. I substitute E2 by B2. Thank you. B1 is equal to 90 degrees minus B2. Check this statement. Let me say equation number 1. Check this one. Check the two equations. Remember, in that equation, if I have to write it down again, I said from here, if I have to write it down again, I say E1 is equals to 90 degrees minus E2. You can see B1 is equal to 90 degrees minus E2. E1 is equal to 90 degrees minus E2. Therefore, we can therefore conclude by saying angle B1 is equals to angle E1. Therefore, angle B1 is equals to angle E1 because they are both equals to 90 degrees minus B2. Both equals to 90 degrees minus E2. And that proves the theorem. That proves the theorem because remember, we wanted to prove that angle B1 is equals to E1. B1 basically is angle DBC. DEB is basically angle E1. So, in our workout, ultimately, we find that E1 is equal to 90 degrees minus E2, B1 is equal to 90 degrees minus E2. Therefore, it means B1 is equal to E1, both equal to 90 degrees minus E2. That is just an example of a possible question in this coming test for that will be written on the 17th, the next week, Monday. It's one of the possible questions. We must know the proof of the theorems. Remember how the diagram looked like? We had to construct, place, learners practice the proof of the theorems, because proving of theorems is one of the possible questions that we can expect in this coming test, or even in June exam, September exam, even in the final examination. It's one of the possible questions. So we need to be prepared to prove. We need to know how to prove the theorems. Thank you. I want to take you through. You remember the first theorem that we did? I believe it is the theorem that states the line joining the center of the circle to the midpoint of a chord is perpendicular to a chord. That is also a possible theorem that you can be expected to prove. So you as learners, place your practice. Teachers, take our learners through the proof of that theorem.